All right, guys, hello, back with you here. We're still dealing with radicals, but now we're going to deal with something a little bit different. These fractional exponents, okay? These are also called rational exponents, okay? So um, before we get into, in this video, all we're going to do is review some exponent rules and then work on converting between one form and the other, okay? And then in another video, we'll actually deal with kind of multiplying and dividing and all sorts of stuff. But before we get into actually converting, we're just going to review some exponent rules you would have learned in Algebra 1, and then a couple of new ones that are going to help us to convert. Okay, these older exponent rules are more going to apply to another video later on that we'll do. Okay, so for this one, again, I went over a little bit of these. I'm actually going to include me actually explaining those in the next video because we'll more use these then. But so here, what we're going to be applying, these are the ones that are more going to apply to the actual converting we're going to do in this one. Okay, so these new exponent rules, basically, this is saying if I just have some radical with an index and a radicand inside, basically what I can do is I can rewrite that, okay, or this is equivalent to saying x to the 1 over whatever the index is, power, okay? So this is saying that a radical, you can rewrite a radical as a fractional exponent, okay? And then number 6, this what this rule says, it's kind of the same thing, but it's saying like if you have a fractional exponent that has, right, a numerator and a denominator. So you notice this one is 1. Okay, and these rules kind of go together. But so yeah, the same a way to write that as a radical would be, right, the denominator is the index and the numerator is going to be whatever my radicand would be raised to in the radical. Or you could also write it as, in parentheses, the radical with the denominator as the index, and then in parentheses, outside the parentheses, raised to that numerator power. So this applies to number 5 here too, because this is a radical with an index, okay? And we could say inside is x to the first, right? So that thing, that radicand, right, whatever the exponent is in there, would be the numerator, right? So 1, and then the index would be that denominator of the fraction exponent, okay? So again, it'll help when we convert some of these, okay? But that's the deal there. Okay, so now that we went over these rules, we can kind of convert between the two forms, okay, using mainly these rules 5 and 6, okay? So looking at number 1, again, we look at what form it gives me. So this gives me the fractional exponent or the rational form, and I want to write that as a radical, okay? So again, thinking about this rule here, okay, so number 5, right? I could, if I have a fractional exponent, x to the 1 over something, right? Look how that's written as a radical. That's x to the first inside, or again, you don't even need that 1. That's just plain old x. And that's what root it is. So if it's x to the 1/3, that's going to be just rewritten as the cube root of x, okay? So that's how I can write that. Again, making the connection, the index and the denominator go together, okay? Second one, I look at this. So this is saying the 4th root of x to the 3rd. Okay, the 4th root of x to the 3rd. So again, it's going to be x as a fractional exponent, okay? But again, it's just tying together, okay, which one of these is my numerator? My numerator, m, is going to be whatever the term is, or whatever the exponent is inside the radical. So it's going to be 3 over, and then the index is the denominator, so 3 over 4. Okay, so x to the 3/4 power is how I can write the 4th root of x to the 3rd. Okay, hopefully as we go over some more of these, you'll start to catch on. Number 3, the square root. Okay, and it's easy to miss that the square root, right? It doesn't write it, but this has a 2 index. Okay, so you could even include that in there. That might be helpful. Every time you see a square root, put that 2 index. Okay. So what's this saying? This would be more like this form down here, okay? So again, I'm writing this in the fractional exponent form. So this would be x to the what? And again, whatever power the radical is being raised to, or the thing in the radical, again, these are equivalent. That second exponent will go in the numerator, okay? So it's going to be x over, or x to the 7 over and then the index on the bottom, 2. So x to the 7/2 power is how I could write that. Okay. Fourth one, so it gives me the radical x to the 4/5. So again, it's tricky. Again, we're going the other way now. Okay. So again, I can start with my radical and the x. I know those are going to be involved. And then again, it's thinking, okay, this 4, where's that going to go? Again, it helps to have this guide kind of, if you write this on any sheet or wherever you do these problems, it's helpful to have this right next to you as you do it. So x, again, the numerator goes in the group with the x, so that's x to the 4th, and then the denominator is the index, so that's going to be a 5. Okay, so this is the 5th root of x to the 4th. Again, normally we don't see radicals with this big of an index, but they definitely are a thing. They can exist, okay? Number 5, x to the 3/2. Okay, so again, thinking about this, the numerator is in a group with the x, the denominator is what the index is. So it's going to be a square root. Again, you can write the 2 there if you want, but that's saying a square root of x to the 3rd. 2 more. Number 6. Look how similar this is. Okay, so this is going to be really similar to this one, but it's going to be x with a fractional exponent, right? I like the index is what stands out to me first. It's a cube root. So I usually, when I do these, I write the denominator first. That's over 3, and then the 2 in a group with the x goes on top. So x to the 2/3. So look how similar these are, right? 5 and 6. I did that on purpose. So, okay, last one. X to the 9/4 power. Okay, so again, writing it as a radical. What's the index? Again, the index is whatever the denominator is, the bottom. So it's going to be 4. And then x to the 9th is how you could write that. Now, one thing I forgot to mention with 5 and 7 specifically, technically number 3 as well, but we'll forget it. Notice when you write these in radical form, to fully simplify these, what we can do, right? Because when there's more x's than what the index is, right? Technically, we could expand this number 5 and say, okay, that's the square root of x times x times x, right? And you remember our rule with simplifying radicals that says if I have a pair, 2 or more, right? For this one, if I have a pair, I can pull that out. So I could write that technically the fully simplified version of this would be x times the square root of x, right? Because I have this pair of x's in here, okay? So if you were asked to simplify this as well and not just convert, you could do it like that, okay? And again, it doesn't apply to this one because this would just be 3 x's in here, and I would need 4 for a group, right? There's 1 x, and I would need a group of 3. Again, this one you could do if you expanded it all out, but again, I won't worry about that. I would need a group of 3 here, and I only have 2 in there. But then the last one for number 7, right? Think about this. I have 9 x's in the radical, and I would need a group of 4 to pull out, okay? So again, rewriting that, if you wanted to expand it and write all your x's in there, you can. But I would end up having 2 groups of 4 with 1 x left inside. Okay, so that would be written as x squared times the 4th root of x. Okay, and if that doesn't make sense, I do some problems like that with simplifying radicals in another video. You can just search my page for simplifying radicals and you can see that. Okay, so that's all. Well, that's not all with this topic. We're going to go over some more problems involving more multiplying and dividing these terms, okay, in another video. So stay tuned. We'll get into it.